Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be commencing with the projectile motion, and under this projectile motion, we'll be looking at the major formulas of the projectile motion. We'll be looking at series of calculation under this projectile motion. So stick with me till the end and let's enjoy the best out of the lesson. So firstly, let's define what projectile motion is. By definition as displayed on the screen, the projectile motion can be defined as the motion of an object or a body projected upward at an angle into the air and moving under the influence of gravity. So this is the definition of the projectile motion. It is the motion of an object or a body projected into the air at a specific angle and moving under the influence of gravity. So let's have a typical diagram of the projectile motion. So let's say this is our height and we have the horizontal distance. So this is the horizontal distance. So if the body is projected from this point of projection, so this is a typical diagram of the projectile motion. Now this is our angle. This is the angle that the body is projected. You know, from the definition of projectile, we said the body is projected upward into the air at a specific angle and the body is moving or the object is moving under the influence of gravity. So this is a typical diagram of the projectile motion. Now let's look at some major formulas of the projectile motion, and when we are looking at the major formulas, we'll be putting them on this diagram of the projectile motion. So let's look at some major formulas. Looking at the major formulas, the first formula that we have is known as the time taking. So we have the time taking. So this is the first formula, the time taking, which is denoted as the small t. So the formula for the time taking is given as t small t equals to u sine theta over g. So this is the formula for the small t, which is the time taking. So looking at this, we have the, let's say this is our maximum height. So from this diagram, this is our small t. So the time taken from this point of projection to the maximum height is known as the small t. So the time taken from the point of projection to the maximum height is known as the small t. And the formula for the small t is given as u sine theta divided by the gravity. And our u is the initial velocity in meter per seconds. Our theta is the angle of projection. So we have the angle in degrees. So our theta is measured in degrees. And lastly, we have the gravity, which is the g. So we have the gravity, which is measured in meter per second square. And the time taken, which is the t, is in seconds. So this is all about the first formula, which is the time taken, which is given as u sine theta over g. So let's look at some examples under this time taken. The first example, as displayed on the screen, says that a projectile is fired with a speed of 20 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height, and they give us g to be 10 meters per second square. So from this, let's write our given parameters. So from this question, we're given the speed, which is the initial velocity, to be u equals to what? We're giving it as 20 meters per second, and we're giving our angle, which is theta, to be equals to 30 degrees. And also we're giving g to be equal to 10 meters per second square. And the question asks us to calculate the time taken to reach the maximum height. So from our formula, we said the time taken is equal to u sine theta over g. And applying this formula, we have our t, which is the small t, to be equal to u sine theta over g. So putting this, we have our t, which is the time taken, to be equal to what's our u? We have 20 multiplied by what's our sine theta? We have sine 30 degrees divided by our g, which is 10. So in this case, our t will be equal to 20 multiplied by what is sine 30? Sine 30 is 0.5 divided by 10, and our t will be equals to 20 times 0.5 will give you 10. So we have t equals to 10 divided by 10. And when you divide this, we have t equals to 1 seconds. Always note the SI unit for t. So in this case, t is equal to 1 second. So 1 second is correct to this kind of question. And the last question we have on this time-taking aspect says that a body is projected with an initial velocity u at an angle theta to the horizontal. The time taken by it to reach the maximum height is given by the expression A 2u sin theta over g, B u square sin theta over 2g, C u sin theta over g, and D u sin theta over 2g. So from this question now, you can see they are asking us for the formula for time taking to reach the maximum height. So looking at what we have on the board, we said the time taking is given as t equals to u sin theta over g. So looking at all these options, the correct option, which is the time taking, is option C, which is given as u sin theta over g. So option C is correct to this kind of question. And that will be all on time taking. So let's move to another formula under the projectile motion. Moving to the second formula we have under this projectile motion, the second formula is known as the time of flight. So we have the time of flight, which is denoted as the big T. You can see the time taken is denoted as the small t, while the time of flight is denoted as the big T. And by definition, the time of flight is defined as the time taken which requires a projectile to return to the same level where it was projected. This is the definition of the time of flight. So from this diagram, you can see the time taken is the time that it takes the projectile to reach the maximum height. But the time of flight is the total time taken. So the time of flight is the total time taken by which the projectile requires to return to the same level that it was projected. So this is the time of flight. And the formula for this time of flight, which is the big T, is denoted as 2t. So this is the formula for this time of flight, because this t is the time taken from the point of projection to the maximum height, and we have another t here, which is the same as the point of projection to where it was projected. So this is another t, and these two t are what form the big T, which is the time of flight, and that is why we have the formula for the time of flight to be equals to 2t. So we have the first t and the second t, because these two t are the same time that it takes the body to reach the maximum height. So we have this big T to be equals to 2t. So the formula for time of flight is equal to 2t. And we know that our t, which is equal to u sin theta over g. So our time of flight, which is the big T, will be equal to 2 open brackets. What is our small t? Our small t is u sin theta over g. So we can put this as u sin theta over g. So when you solve this, you have our big T to be equal to 2u sin theta over g. So this is the formula for our big T, which is the time of flight. So we have our big T, which is the time of flight, to be equal to this formula. So let's look at some examples under this time of flight. So the first example, as displayed on the screen, says that a projectile is fired with a velocity of 20 meters per second at an angle of 30 degrees to the horizontal. Calculate the time of flight and take g to be 10 meters per second square. So from this question, let's write our given parameters. We are given our u, which is the initial velocity, to be equal to 20 meters per second. And we are also given our angle, which is theta, to be equal to 30 degrees. And lastly, we're given our g, which is the gravity, to be equal to 10 meters per second square. So, and they ask us to calculate our big T, which is the time of flight. So to calculate our big T, we know that our big T is given as t equals to 2u sin theta over g. So this is the formula for our big T, which is the time of flight. So putting our parameters in the formula, we have our big T to be equals to 2 multiplied by our u. What is our u? Our u is 20 meters per second. multiply by sine 30, which is 0.5, and we can divide it by our gravity, which is 10 meter per second square. So we have our big T to be equal to 2 multiplied by 20 multiplied by 0.5 divided by 10. So when you divide this, we have our big T to be equal to, so when you multiply 2 multiplied by 20 multiplied by 0.5, you have 20. So 20 divided by 10, our big T will be equal to 2 seconds. And this is our final answer to questions of this type. So let's look at another example under this time of flight. The second example, as displayed on the screen, says that a stone is projected with an initial speed of 25 meters per second at an angle of 37 degrees to the horizontal. Find the time of flight. So from this question, we are given the sine 37 to be 0.6 and we are giving gravity to be 10 meters per second square. So writing our given parameters, we have our u to be equal to 25 meters per second, followed by our angle, which is equal to 37 degrees. And lastly, we're given our g to be equal to 10 meters per second square. And the question is asking us to calculate our big T, which is the time taken. So from what we know that our big T is equal to 2u sine theta over g. So writing our formula, we have our big T to be equal to 2u sine theta over g. So from this formula, we can put our parameters. So we have our 2 multiplied by, what is our u? Our u is 25 meters per second. So we have 25 multiplied by, what is our angle? We have sine 37 divided by our gravity, which is 10. And from the question, we're given our sine 37 to be equal to 0.6. So we have our t to be equal to 2 multiplied by 25 multiplied by 0.6 divided by 10. So when you solve this, 2 multiplied by 25 multiplied by 0.6 will give you 30. And 30 divided by 10, which is our gravity. So our t will be equals to 3 seconds. So this is our final answer to question of this type. So let's move to another question under the time of flight. And the last question under this time of flight, as displayed on the screen, says that a stone is projected at an angle of 60 degrees and an initial velocity of 20 meters per second. Determine the time of flight. So to this kind of question, we are given our parameters. So the first parameters that we are given is an angle, which is 60 degrees. And also we're given our initial velocity, which is u, to be equal to 20 meters per second. And our gravity, of course, which is 10 meters per second square. And this question is asking us to calculate our big T, which is the time of flight. So from what we know that our time of flight, which is the big T, is giving us T equals to 2u sine theta over g. So putting our parameters in this formula, we have our big T to be equal to 2 multiplied by, what is our u? Our u in this case is 20 meters per second multiplied by, what is our angle? We have our sine 60 degrees. So divided by our gravity, which is 10. So solving further, we have our t to be equal to 2 multiplied by 20 multiplied by our sine 60 is 0.8660. When you press this in your calculator, you have 0.8660. And our 10, which is the gravity. So when you solve this, when you multiply 2 multiplied by 20 multiplied by 0.8660 divided by 10, you have your 34.6 divided by 10. And our final answer will be given as 3.46 seconds. So this is our final answer to questions of this type. So 3.46 seconds is correct. And this will be all on the time of flight. So let's move to another formula under the projectile motion. And the third formula that we have under this projectile motion is known as the maximum height. So we have the maximum height which is denoted as the big H. So this maximum height, by definition, the maximum height is the highest vertical distance from the horizontal point or horizontal plane of projection. So this is the definition of the maximum height. It is the highest vertical distance from the horizontal plane of projection. And the formula for this maximum height is given as big H equal to U square sine square theta over 2G. So this is the formula for our maximum height. The maximum height is given as U square sine square theta over 2G. So this is the formula for our maximum height. So our U is still the same thing, which is the initial velocity, and our theta is still the same angle of projection, and our G, which is the gravity, is still the same. So this is the maximum height. But there are some common questions that they do ask under this maximum height. They can ask you that what angle must a body be projected to attain the maximum height? So for this kind of question, a body must be projected at the angle 90 degrees to attain the maximum height. So let's take for example, let's say this is our projectile. You can see this is at angle 90 degrees already. So if the body is projected at this angle 90 degrees, definitely the body will attain a maximum height because it will go like this. So we will have our maximum height, which is the H. But let's say the body is projected at another angle, let's say like maybe like 40 degrees. You can see it won't have a maximum height compared to the body projected at 90 degrees. So this will be the maximum height for that 40. And also, let's say the body is projected at another angle, maybe like 60 degrees. You can see it won't still have a maximum height compared to the body projected at 90 degrees. So you can see the difference between the body projected at 90 degrees, 60 degrees, and 40 degrees. So for a body to have a maximum height, the body must be projected at angle 90 degrees. So this is for a body to have a maximum height. So how do we get our H mass? So to get our H mass, which is the maximum height, remember we said for a body to have the maximum height, it must be projected at angle 90 degrees. So we can put our 90 degrees to this formula. So let's say we have our H to be equal to U square sine square theta. So what is our theta? Our angle will be 90 degrees because that is the angle that a body must be projected to reach the maximum height. So our H mass will be equal to U square sine square theta over 2G. So we have our 2G. So when you do this further, we have our H mass to be equal to, what is our U square? So we have U square sine. So sine 90 degrees is given as 1. So we have our 1 square divided by 2G. So if you press sine 90 in your calculator, you have 1. And because it is sine square theta, that is why we are having 1 square. So our H mass formula will be given as U square over 2G. So this is the formula for our H mass. So if they ask you to calculate the H mass when you are not given the angle, if they don't give you the angle and they ask you to calculate the maximum height, you can easily use this formula, which is H mass equals to U square over 2G. Because for a body to reach the maximum height, the body must be projected at angle 90 degrees. So if you are not given the angle, you can just simply use this formula, which is H mass equals to U square over 2G. So this is our formula for the H mass. So let me just write this here. So this is another formula for the H mass. So this H mass is useful if you are not given the angle of projection. So if you are only given the initial velocity and the gravity, you can just simply use this H mass to get the maximum height. So far you are not given the angle of projection. So let's look at some examples under this maximum height. The first example under this maximum height as displayed on the screen says that an object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is. So this kind of question, let's write our given parameters. So we are given the initial velocity, which is u. So our u is equals to 80 degrees. And we are also given our gravity, which is 10, obviously. And we are also given our angle, which is 30 degrees. and they ask us to calculate the maximum height, which is unknown. So in this kind of question, we are not going to use our h mass because we are given the angle. So the angle is known, which is 30 degrees. Assuming they did not give us the angle, we can use our h mass to calculate the maximum height. So from what we know that our maximum height, which is the big H, is given as u square sine square theta over 2d. So we can write our formula, which is the maximum height, to be equal to u square sine square theta over 2g. So putting our parameters in this formula, we have our maximum height to be equal to. So what is our u? Our u is 80 meter per second. So we have 80 meter per second square multiplied by what is our sine theta? So we have our sine square 30 degrees. So our theta is 30 degrees. So you can see the theta to be 30 degrees. So advancing further, we have our h to be equal to 80 square multiplied by what is sine 30? So to do this sine 30 square, you just have to find sine 30 first before you square it. So finding sine 30 first, we have sine 30 to be 0.5. So we can now square that 0.5 after finding sine 30 divided by our 2 multiplied by our gravity, which is 10. So when you multiply all of this, we have our big H to be equal to, when you multiply 80 square multiplied by 0.5 square, you have 1600 divided by 2 multiplied by 10 will give us 20. So our big H will be equal to 1600 divided by 20. So when you press this to your calculator, you have our big H to be equal to 80 meters. So the SI unit for the maximum height is in meters. So our big H will be equal to 80 meters. And this is given as our final answer to question of this type. So let's look at another example under the maximum height. The second question we have, as displayed on the screen, says that a projectile is fired with a velocity of 20 meters per second at an angle of 30 degrees to the horizontal. Calculate the maximum height reached. So to this kind of question, we are given our parameters, we are given our u to be equal to 20 meters per second. Also, we are given our g to be equal to 10 meters per second square. And we're also given our angle, which is theta, to be equal to 30 degrees. And the question is asking us to calculate the maximum height, which is the big H, to be unknown. So looking at this, we are going to use our h equals to u square sine theta over 2g. We are not going to use this h mass because we are given the angle. Assuming we are not given the angle, we are going to use this h mass formula. So using this h equals to u square sine theta over 2g, we have our h to be equal to u square sine square theta over 2g. So putting our parameters in this formula, we have our h to be equal to, what is our u? Our u is 20. So we have 20 square multiplied by sine square. What is our theta? Our theta is 30 degrees divided by 2g, which is 2 multiplied by 10. So in this case, you can see our h is equal to, what is 20 square? 20 square is equal to 400 multiplied by, I said if we want to get sine square theta, we must first find the sine theta before we square it. So sine theta is equal to 0.5. So when we know that sine theta is equal to 0.5, we can then square it. So we have divided by 20. So in this case, our h will be given as 400 multiplied by, what is 0.5 square? We have 0.25 divided by 20. So when you do this further, our h will be equal to 400 multiplied by 0.25 will give you 100. So we have 100 divided by 20. And our h will be equal to 5 meters. And this is our final answer to question of this type. So let's look at the last example under the maximum height. And the last question we have says that a ball is projected with an initial speed of 25 meters per second at an angle of 37 degrees to the horizontal. Find the maximum height reached. So to this kind of question, we're given our initial velocity, which is u, to be equal to 25 meters per second. And we're also given our angle, which is theta, to be equal to 37 degrees. And we're given our gravity to be equal to 10 meters per second square. And the question is asking us to calculate our h, which is the maximum height reached. So to this kind of question, from what we know that our h is equal to u square sine square theta over 2g. So putting our parameters in this formula, we have our maximum height to be equal to, what is our u? Our u is 25. So we have 25 square multiplied by sine square 37 divided by our 2 multiplied by 10, which is the gravity. So in this case, we have our h to be equal to, so when you press 25 square in your calculator, you have your 625 multiplied by, so to get sine square 37, I said we have to get sine 37 first before we square it. So sine 37 is equal to 0.6. So you have your 0.6 square divided by 20. So you have our h to be equal to, so 625 multiplied by 0.6 square will give you 0.36 divided by 20. So our h will be given as, when you press 625 multiplied by 0.36 in your calculator, you have 225 divided by 20. So our h will be given as, so 225 divided by 20 will give you 11.25 in meters. So this is our final answer to question of this type. And this will be all on the maximum height. So let's move to the last formula on projectile, which is the range. And the last formula under projectile, we have the range. So this is called the range. So we have our fourth formula, which is the range. And it is denoted as R. So for this range, by definition, the range can be defined as the maximum horizontal distance covered from the point of projection till where the body reach the projection plane again. So this is the range. It is the maximum horizontal distance covered from the point of projection to where the body hits the projection plane again. And this is the definition, or the simple definition, of the horizontal range. So for our range, the formula for range is given as R equals to u square sine 2 theta over g. So this is the formula for our horizontal range, which is given as u square sine 2 theta over g. And looking at this range, there is always a question that they do ask under this range, which is also the R mass. So we have our range mass, which is the R mass. So our range mass, which is the R mass, they always ask that what angle will a body be projected to reach the maximum horizontal range. So the angle that a body can be projected to reach the maximum horizontal range is known as the R mass. And to get this R mass, the body must be projected at an angle 45 degrees. So to reach the maximum range, the body must be projected at an angle 45 degrees. So our R mass will be given as, so putting this in this formula, we have our R mass to be equal to, what is our U square? So we have U square sine 2 open bracket 45 degrees over G, which is our gravity. So our R mass will be given as, so U square. So to get sine 2 theta, we have to multiply this theta by 2 before we find the sine angle of that theta. So we have our sine. So 2 multiplied by 45 degrees will give us 90, and divided by the gravity. So our R mass will be given as U square sine 90. So sine 90 is 1. So we have U square times 1 over G. So R mass will be given as U square over G. So this is the formula for R mass if they don't give you the angle and they ask you to calculate the maximum range. So for a body to cover the maximum range, the body must be projected at an angle 45 degrees. Because let's say this is our point of projection. If the body is projected at 90 degrees, it will only go up and not cover the maximum range. And let's say the body is projected at angle 60 degrees, so still the same, it will not cover the maximum range. But if the body is projected at angle 45 degrees, it will cover the maximum range because it will be at the midline between the 90 degrees and the horizontal ground. So the body must be projected at angle 45 degrees to cover the maximum range. So this is what this R mass is telling us about. So from what we did earlier, our R mass is equal to U square over G. So this is another formula for the R mass, and it must be projected at angle 45 degrees. So far we are not given the angle, we can use this R mass to get the horizontal range. And another thing about the range is that sometimes they might ask us to calculate the range of a body when the body is projected from a certain vertical height. So looking at this diagram, you can see the body is projected from the horizontal range. So you can see the body is projected from horizontal distance. So you can see the range. But what if the body is projected, let's say we have another projection plane and the body is projected from this vertical height. So let's say the body is projected from this height. You can see the difference between these two diagrams. You can see in this diagram, the body is projected from the point of origin, which is the horizontal plane. But in this case, the body is projected from the vertical height. So you can see there's a particular height from which the body is projected. Let's say this is an aeroplane. So this is a plane, and the plane is going to drop a bomb. You can see the plane will be going to this distance, and the bomb will go like this in this projection. So let's say they ask us to calculate the range in this case. How do we get the range? Remember that the formula for this range is for the horizontal plane. But if they are asking us to calculate a vertical range, our range will be given as R equals to U multiplied by the time taken, which is T. So this is another formula for the range if it is vertical. So our range will be given as our initial velocity multiplied by the time taken. Looking at this, you can see this is the height reached. So it is just like saying that the body is projected from this point of projection to this end of the plane. So you can see from this point we have another t. So this is the t, which is the time taken that we have in this formula. And the initial velocity that that body is going through is known as the u. So our range will be given as u equals to t. And to get our t for this case, we have to use the formula for this height. So our h will be given as 1 over 2 g t square. So to get this time taken, we have to get our h to be equal to 1 over 2 gt square. So these are the formula to note when calculating a vertical range. The first formula is r equals to u multiplied by t, and the height will be given as 1 over 2 gt square. So to get our t, we have to use this formula, and when we now get the t, we can now use that t to calculate our range, which is given as u multiplied by t. So let's look at some examples under this range. So the first question we have under this range says that for a projectile, the maximum range is obtained when the angle of projection is A 60 degrees, B 30 degrees, C 45 degrees, D 75 degrees, and E 90 degrees. So this question is asking us that what angle must a body be projected to attain the maximum horizontal range? And we said that the angle that the body must be projected must be at an angle 45 degrees to attain the maximum horizontal range. So 45 degrees is correct to this kind of question. So option C is correct. And the second question we have says that a projectile is fired with a speed of 20 meters per second at an angle of 45 degrees to the horizontal. Calculate the range. So to this kind of question, we're given our initial velocity, which is u. So our u is equal to 20 meters per second. And we're also given our angle, which is theta, to be equal to 45 degrees. And we're also given our gravity, which is g, to be equal to 10. And the question is asking us to calculate the horizontal range, which is unknown. So from what we know that our r, which is the horizontal range, is given as r equals to u square sine 2 theta over g. So we have our r to be equal to u square sine 2 theta over g. So substituting our parameters, we have our r to be equal to, what is our u? Our u is 20. So we have 20 square multiplied by, what is sine 2 theta? So we have our sine. So we have our sine 2 45 degrees divided by our gravity, which is 10. So in this case, we have our r to be equal to, what is our 20 square? So we have 400 multiplied by, so to get sine 2 theta, you have to multiply 2 by 45 before you find the sine of that angle. So we have our sine 2 times 45. So we have our r to be equal to 400 multiplied by sine 90 degrees. So our r will be equal to 400 multiplied by, what is sine 90? Sine 90 is 1 divided by our 10, which is the gravity. So r is equal to 400 divided by 10. Our r will be given as 40 meters. And this is our final answer to question of this type. Remember that when we say we are finding sine square theta, you have to find the sine theta of that angle before you square it. But when you are dealing with sine 2 theta, you have to multiply that theta first before you sine the angle. And that is why we have sine 2 multiplied by 45, and we have sine 90, and so on and so forth. So this is all about the first example. Now let's look at another question under this range. The second example, as displayed on the screen, says that a ball is projected with an initial velocity of 25 meters per second at an angle of 30 degrees to the horizontal. Calculate the range of the projectile. So we are giving our g to be 10 meters per second and our sine 60 to be 0.8660. So from what we are giving our u, initial velocity, to be equal to, so our u is given as 25 meters per second. So we have 25 meters per second. And we're also giving our angle, which is the theta, to be equal to 30 degrees. And we're also giving our gravity, which is g, to be equal to 10 meters per second. And the question is asking us to calculate our range, which is equal to unknown. So in this kind of question, we're giving our angle. So we'll be using our horizontal range formula. And from what we know that our range is equal to u square sine 2 theta over g. So substituting our parameters in the formula, we have our u square. So u is equal to 25 square multiplied by sine 2 open bracket 30 degrees divided by our gravity, which is 10. So solving this further, we have our r to be equal to, what is 25 square? That is 625 multiplied by sine. So to get sine 2 theta, we have to multiply this 2 multiplied by 30 before we find the sine. So we have 2 times 30 divided by our 10. So our r will be equal to, so we have 625 multiplied by sine 60 divided by 10. So when you multiply sine 2 times 30, so you have your sine 60. And that is how we get this sine 2 theta. So our r will be given as 625 multiplied by 0.8660 divided by 10. So our r will be given as, so 625 multiplied by 0.8660 will give you 541.25 divided by 10. So our r will be equal to 54.1 meters. So r is equal to 54.1 meters, and this is given as our final answer to question of this type. So let's look at another example under this range. And another example we have says that a ball is projected horizontally from the top of a hill with a velocity of 30 meters per second. If it reaches the ground 5 seconds later, the height of the hill is. So to this kind of question, you can see they are projecting the ball from a top of a hill. So definitely you are not going to use this horizontal range again because the body is projected from a top of a hill. So there's definitely a vertical height or a vertical distance from the horizontal floor. So definitely you are not using this horizontal edge because it is from a top of a particular height. So the given parameters that we are given in this question, we are given the initial velocity, which is u, to be equal to 30 meters per second. And we are also given the time, which is t, to be equal to 5 seconds. And our gravity, of course, will be equal to 10 meters per second square. And the question is asking us to calculate the height of the top of the cliff. So to this kind of question, I told you that the formula for the height will be given as 1 over 2 gt square. So this is the formula to calculate the height of the top of the cliff. So looking at this, we have our height to be equal to 1 over 2 gt square. So substituting our parameters in this height, we have our height to be equal to, what is our gravity? So 1 over 2 multiplied by 10 multiplied by our t square, which is 5 square. So we have our h to be equal to, so this 1 over 2 can cancel 10. So when you cancel it, you have 5 multiplied by, what is our 5 square? So 5 square is 25. So our height in this case, we're given as 125 meter. So when you multiply 5 by 25, you get 125. So 125 meter is correct to this kind of question. So the height of the top of the cliff is 125 meters. So you can see the difference between the horizontal range and the vertical range. So the height is 125 meter, and that is our final answer to question of this type. And the last example we have under range says that a ball is projected horizontally from the top of a building 20 meter high with a speed of 10 meter per second. Calculate the horizontal range of the ball. So looking at this question, you can see the question is saying that the ball is projected from a top of building which is 20 meter height. So you can see the height of the building is 20 meters. So the ball is projected from a particular height which is 20 meters. So you are not going to use this horizontal range again because they are giving us a height that the ball is projected. So from what we are given in this question, we are given the height which is equal to 20 meters, and we are also given the initial velocity which is u to be equal to 10 meter per second, and of course the gravity will be equal to 10 meter per second square. And the question is asking us to calculate the horizontal range or the range. So in this case, we are asked to calculate the range in this question. So from what we know that the range is equal to u multiplied by the t. But in this case, we are only having u, but we are not having t. So to get the range, we must find this t. And to find this t, we can use this formula, which is h equals to 1 over 2 gt squared, to find our t first. And when we get the t from this formula, we can use this t to calculate our range by multiplying it with the initial velocity. So our h will be given as, what is our gravity? 1 over 2 multiplied by 10, multiplied by, what is our t square? So t square is unknown. So the h is 20 meters. So we have 20 is equal to 1 over 2. So you can just calculate this directly. So 1 over 2 multiplied by 10 will give you 5, because this 2 divided by 10 will give you 5. So we have 5 multiplied by t square. So we have our 20 to be equal to 5 t square. So t square will be given as 20 divided by 5, and our t square will be given as 4. But we have to calculate t and not t square. So our t will be given as square root of 4. Our t will be given as 2, because when you calculate the square root of 4, you get 2. So t is equal to 2 seconds. And now that we have gotten our t, then we can then calculate our range, which is what the question is asking. So our range will be given as u multiplied by t from this formula that we have. So our range is equal to u multiplied by t. And when you multiply this, you have our range to be equal to, what is our u? Our u is 10 meters per second. So you have 10 multiplied by, what is our t? Our t is 2 seconds. So our r will be given as 20 meters. And this is our final answer to question of this type. And this will be all about the range. And just know that in order to solve any question on the projectile motion, you have to master all this formula, which is the time taking, the time of flight, the maximum height, the h mass, which is the maximum height when the angle is not given, and also the horizontal range and the r mass, which is the range when the angle is not given, and lastly the vertical range, which is the r when a body is projected from a particular height. So this will be all on the projectile motion. And if you found this video helpful, or this video help you understand the projectile motion, don't forget to give this video a thumbs up so more learners can find it. And don't forget to subscribe to Tech and EduSpark Hub for more tech content and educational school lessons. And lastly, don't forget to turn on the notification bell so you won't miss any updates from Tech and EduSpark Hub. And attempt the question on the screen and let me know your answer in the comments, and I'll let you know if you are right or wrong. And until next time, keep learning, keep coding, and I will see you in the next one.